So, good evening to all of you. So, let us start the class from where we have left behind. Just give me a minute so that I can present my screen. Is my screen visible to all of you?
Yes, sir.
Okay, so this was the data book which I have given to you in your Google Classroom some 1 week before. So we will be using this data book today to solve the problems related to rivet joint. Fine. Okay, let me open my slides. Can you please say that whether my slides are visible or not? Please tell whether my slides are visible or not.
Visible, yes, sir. Yes, sir, visible.
Okay. Fine. So I think we were solving problems related to rivet joint, and in the last class we have solved this problem. So let us continue our discussion and let us solve the remaining problems of strength equations related to rivet joint. So let us read the problem. The problem is a double riveted double cover butt joint in plate 20 mm thick is made with 25 mm diameter rivet at 100 mm pitch. The permissible stresses in tension, shear and crushing are 120 megapascal, 100 megapascal and 150 megapascal. Find the efficiency of the joint. So first of all, let us identify what type of rivet joint is given in the problem. I can see from the very first line that the rivet joint which is being used is nothing but double riveted double cover butt joint. That means I can draw the rivet joint like this. Okay, just wait for a minute. Can anyone say that why this protected view is coming? If you know any way to remove this protected view.
Sir, close this window and restart again.
Okay, because otherwise I will not be able to write in the PPT. That is the main problem. Okay, yes, I have opened. Again, the same thing is coming. So, what to do with this? Because I will not be able to write then. Okay, now it has came, I think. Slide.
Yes,
Just,
sir.
just wait. Whether I can write or not, that I have to see. Because if I cannot write in the PPT, then the class will be of waste. Just wait. Okay, we were discussing this problems like so. now I can write fine. So what we need to find out in this problem? We need to find out the efficiency of the joint. In order to find out the efficiency of the joint, first let us see which type of rivet joint is used in this problem. In the very first line, it is clear that the type of rivet joint used is double riveted double cover butt joint. That means this is your plate number 1. You have joined this first plate with the second plate by butting process. Okay, and we have used double riveted double cover. So this is your first cover, this is your second cover, and we have used double riveted. That means 2 rows of rivets are used. So if I want to join first plate with first and second cover, I have to use 2 rows of rivet. That is the meaning called double riveted. That means this is 1 row of rivet and this is another row of rivet. Similarly, if I want to join the second plate with both the top as well as the bottom cover, I have to use 2 rows of rivet. 2 rows of rivet. This is the first row of rivet and this is the second row of rivet. So this is nothing but my double riveted double cover butt joint. Is it clear? Is the diagram clear to all of you? Any doubt in this diagram, in this schematic part of this problem?
No, sir.
Okay. So what is given? Thickness of the plate is given to you. Both the plate are of having same thickness, that is T is given to you 20 mm. It is made with 25 mm diameter rivet. Rivet diameter, that means small d is given to you 25 mm. Pitch is given to you small p equal to 100 mm. And the permissible stresses in tension, that means sigma t permissible is 120 megapascal. Tau permissible, that is shear stress, is 100 megapascal, and crushing stress, that is sigma c permissible, is 150 megapascal. I need to find out what? I need to find out the efficiency of the joint. I know that the efficiency of the joint is given by the expression called the strength of the riveted joint divided by strength of the unriveted solid plate, and that efficiency is nothing but the minimum value of either PS or PT or PC divided by strength of the unriveted solid plate, which is P T sigma T, where P is your pitch, T is the thickness of the plate, and sigma T is your permissible tensile strength. So what I need to find out initially, I need to find out what is the value of PS, what is the value of PT, what is the value of PC. PS, PT and PC are nothing but shear strength, tensile strength and crushing strength of the rivet. We have already seen that how we can find out the values of PS, PT and PC. Once we got the value of PS, PT and PC, then we will compare the 3 values and we will find out the minimum of either PS, PT or PC. We will divide it by PT sigma T. We will get the efficiency of the rivet joint. So let us find out shear failure of rivet, that is PS. It is what? Pi by 4 d square tau into n. But in this problem, the type of rivet joint used is double riveted double cover butt joint. So this is the diagram. This is the diagram of the rivet joint. Fine. You can see, sorry, here we will get one more rivet. My diagram is wrong. I will get one more rivet over here and one more rivet over here. So you can see that for this part, that means when plate A is connected with both the cover plate, shearing is occurring two times. First time shearing will occur over here and second time shearing will occur over here. Similarly, for when plate B is connected with both the cover plate, again shearing is happening two times, one over here and one over here. So I can modify the shear strength of the rivet as 2 times of pi by 4 d square tau into n. Why this 2 is coming outside? Because 2 times shearing is happening. If shearing would have happened one time, then this would have become 1. Okay. And what is n? N is the number of rivet per pitch length. Since in the problem it is given that a double riveted double cover butt joint, so number of rivet, that is n, is what? It is 2. Remaining values are given to you. Just substitute those values and get the value of shear strength of the rivet, and that is nothing but 196349.54 Newton. Is it clear so far? Shear strength of the rivet. Any doubt so far? कोई डाउट है किसी को? Hello.
Yes.
Okay. Next is tensile failure of the plate between rivets. I know the equation, that is P minus D into T into sigma T. P is pitch of the rivet, D is the dia of the rivet, T is the thickness, sigma T is permissible tensile stress given in the problem. Substitute it, you will get the value of tensile strength of the rivet. That is how much? 180 into 10 to the power 3 Newton. Third one is I need to find out the value of PC. What is PC? Crushing strength of the rivet, and it is given by the expression D into T into sigma C into N. Again here N will be what? It is 2, because in the problem it is given that it is a double riveted joint. So for a double riveted joint, value of N is 2. D, T and sigma C is given in the problem. Just substitute these values in this equation of PC and get the value of PC. So finally you are getting PC as 150 into 10 to the power 3 Newton. Then we will use the equation of efficiency. In this efficiency equation, we have to see the minimum value of either PS, PT or PC. So from we are getting PC as 150 into 10 to the power 3, PT as 180 into 10 to the power 3 and PS as 196349.54 Newton. So out of PS, PT and PC, PC is the smallest value. So eta will be 150 into 10 to the power 3 divided by PT sigma T. P is the pitch given in the problem. T is the thickness of the plate again given in the problem, and sigma T is the permissible tensile stress, which is also given in the problem. So just substitute these values in the expression of efficiency. You will get the efficiency of the riveted joint, and it is coming out to be 62.5%. Simple problem, just we have substituted the values in the given expressions and we have got the efficiency. Any doubt so far?
No, sir.
Okay. Let us solve the next problem. Problem is a triple riveted joint is to be made between 6.5 mm plates. Allowable stresses in tension, shear and crushing are 35, 29 and 52.5 Newton per mm square. Calculate the rivet diameter, rivet pitch and back pitch. Zigzag riveting is to be used. Indicate how the joint will fail. Hence, determine the efficiency of the joint. So what is given to you? Thickness of the plate is given to you, that is 6.5 mm, and allowable stresses in tension, shear and crushing are given to you. It has also been told to you that you have to use a zigzag rivet joint. Okay, and the type of joint will be a triple riveted joint. So you have to find out the rivet diameter, rivet pitch, back pitch, which is also known as transverse pitch, denoted by symbol PT. You have to indicate how this joint will fail, and finally you need to determine the efficiency of the joint. Did you understood the problem? कोई डाउट किसी को?
No, sir.
Okay. So by looking at this problem, can you tell me what will be the value of small n? By looking at this problem, can you tell me what will be the value of small n? What is the value of small n in this problem? Hello.
Yes, 3.
Yes, value of n is 3. Why? It is given in the problem that triple riveted joint. That means you are using 3 rows of rivet. Okay, so value of n is 3. Value of n is 3. So let us solve the problem. So see, in this problem, you can see that only one data is given to you. In this problem, you can see that only one data is given to you. That is thickness of the plate. And you need to find out the remaining data such as rivet diameter, rivet pitch and back pitch. So how we can proceed with this problem? Fine. So what you do is that for in such kind of problem, when no data are given to you, only you have been provided with one single data and you have to find out the remaining data. You first check the thickness of the plate. In the given problem, thickness of the plate is how much? It is 6.5 mm. Okay, you go back to your data book. You go back to your design data book. This is my design data book, and you check page number 7.126. This is my page number 7.126. Okay, see, one point is written. That point is diameter of the rivet. If this point, if thickness of the plate is less than 8 mm, obtain the diameter of the rivet, that is small d, by equating the shear strength to the crushing strength. So in my given problem, what is the diameter, what is the thickness of the plate? It is 6.5 mm and it is less than 8 mm. So from design data book page number 7.126, I have to find out the diameter of the rivet by equating shear strength of the rivet with the crushing strength. Shear strength, I know it is how much? Pi by 4 d square tau into n, and crushing strength is d into t into sigma c into n. So equate PS with PC. I can write pi by 4 d square tau into n is equal to d into t into sigma c into n. N cancel, 1d and this 1d get cancelled. Finally your equation is 5 by 4 d into tau is equal to sigma c into t. Or I can write d is equal to sigma c into t into 4 divided by pi into tau. Sigma c is given in the problem, thickness value is given in the problem, tau value is given in the problem. Just equate, just substitute all these values in this particular expression of d. You will get the diameter of the rivet, and that is coming out to be near about equal to 15 mm. Is it clear how I have found out the diameter of the rivet? Any doubt so far? कोई डाउट किसी को?
No, sir.
ओके, बाकी लोग भी रिस्पॉन्ड करो, कोई डाउट है कि नहीं है अभी तक? कोई डाउट है
No,
किसी
sir.
को? ओके,
No, sir.
ओके फाइन. सो ध्यान रखना, जब आपको डेटा नहीं दिया हुआ है, क्या दिया है? ओनली थिकनेस ऑफ द प्लेट इज गिवन टू यू. You have to find out the diameter of the rivet. You have to find out the pitch of the rivet. You know nothing about the you don't have any specification regarding the rivet. In that case, you have to check the thickness value. If it is less than 8 mm, fine. Then you have to equate PS equal to PC. Okay, fine. So I got the value of diameter D. Now since I got the value of diameter D, I have to find out what pitch of the rivet. So I know that pitch of the rivet is how much? It is 3 times the shank diameter of the rivet, that is 3D. So 3 times of 15, that is 45 mm. This is the second part of the problem. What is the third part? Third part is you need to find out the back pitch of the rivet in case of zigzag riveting. So if you recall some few classes back, I have when I was discussing with you regarding the terminologies of rivet, I have told you that the back pitch or transverse pitch or row pitch for zigzag riveting is how much? It is 0.6 times of the pitch of the rivet. Since in the problem zigzag riveting is used, so I will use PT is nothing but equal to 0.6 times of P. So P is how much in the problem? P we got 45 mm. So 0.6 into 45, that is 27 mm. So this is the transverse pitch or back pitch of the problem. That is the second part of the problem. Is it clear? Any doubt so far? Without?
No, sir, clear.
Okay. नेक्स्ट पार्ट ऑफ द प्रॉब्लम इज हाउ द जॉइंट विल फेल. जॉइंट कैसे फेल करेगा? जॉइंट फेल तभी करेगा जब आप shear स्ट्रेंथ का वैल्यू निकालोगे, कंप्रेसिव स्ट्रेंथ का वैल्यू निकालोगे एंड टेंसाइल स्ट्रेंथ का वैल्यू निकालोगे. फिर आप कंपेयर करोगे दैट विच वन इज ग्रेटर एंड विच वन इज स्मॉलर. अकॉर्डिंगली योर जॉइंट विल फेल. सो लेट अस फाइंड आउट PS, PC and PT first. Shear strength of the rivet is given by pi by 4 d square tau into n. Since in the given problem triple riveted joint is used, so value of n will be 3. Tau is given in the problem. D just now we have calculated diameter of the rivet. We can get the value of shear strength. And that is how much? That is 15,374.16 Newton. Next is the tensile strength of the rivet. We know the equation, that is tensile strength is nothing but equal to P minus D into T into sigma T. P is your pitch, we have calculated, that is 45. D is shank diameter of rivet, that is how much? 15. T is the thickness of the plate given in the problem, 6.5 into sigma T, permissible tensile stress given in the problem. I get the value of PT, that is coming out to be 6825 Newton. Crushing strength of the rivet, that is PC, it is given by D into T into sigma C into N. Again D, T, sigma C and N values are provided in the problem. Just substitute these values and get the value of PC. I got PC as 15,356.25 Newton. Now let us compare this PC, PT and PS value. PC is 15,356.25. PT is 6825 Newton and PS is 15,374.16 Newton. That means I can see that PS is greater then PC, then PT. That means I can see that PT value, that is PT value is the least value. PT value is the least value that the rivet can sustain in tension as compared to crushing and shear. So the rivet joint will fail by shear and crushing mode. Since PT is lesser than that of PC and PS, so I can say that rivet joint will fail by shear and crushing as compared to tensile mode. This is the third part of the problem, and the last part of the problem is I need to determine the efficiency of the joint. I know that efficiency is minimum value of either PT or PS or PC divided by PT sigma T. I can see that PT is having the least value, that is 6825, divided by PT sigma T. All the values are given in the problem. Just substitute all these values and get the efficiency. So finally you are getting efficiency as 66.66%. Any doubt in this problem? कोई डाउट है किसी को?
नहीं।
ओके, बाकी लोग रिस्पॉन्ड करो, क्या क्लियर है प्रॉब्लम?
Yes, sir, clear.
Okay, so the strength equations which we have discussed in some last few classes, that means these equations, this efficiency equation, crushing strength equation, tensile strength equation, and this shear strength equations, you can expect such type of problems. You can expect such type of problems. Some more problems are there in the Bhandari book. Please refer to those problems. Okay. Some 2-3 more solved examples are there. Please refer to those problems. Fine. So let us move on to our next topic of this particular chapter, that is the design of rivet joint for boiler shell. Two more topics are left, that is this design of rivet joint for boiler shell and eccentric loading of rivet joint. With this we will end up this chapter. Fine. So before starting before discussing with you regarding the design procedure of rivet joint used for boiler, I hope all of you know what is a boiler. Can anyone define what is a boiler? Can anyone define what is a boiler?
Sir, it is a part of a machine that produces high temperature steam.
That means I can clearly say that boiler is a mechanical equipment in which a steam is produced. Yes or no?
Yes, sir. Yes, sir.
Okay. So now you have understood what is a boiler. Can you predict the shape of the boiler? How a boiler looks like?
Sir, is it a hollow cylindrical shell
Yes,
like
I can say
uh,
that a boiler is cylindrical in shape like this. Yes or no?
yes, sir.
That means if you see clearly, can I say a shape of boiler is somewhat like this? Can I say that the shape of boiler is somewhat like this?
Yes, sir.
Okay, fine. So this is a shape of a typical boiler. Fine. Now see, in boiler means when we design the different parts of boiler, we have to use rivet joint. We have to use rivet joint. See, you can see that this part, this is the longitudinal part of boiler and this is the circumferential part of boiler. See the diagram? I can say that this is the longitudinal part of boiler and this is the circumferential part of boiler. Yes or no?
Yes, sir.
Okay. So you have to connect a longitudinal part with the circumferential part, then only you can get a complete boiler. Yes or no? If you connect circumferential part with longitudinal part, then only you can get a shape of a boiler. Yes or no? Hello, please respond.
Yes, sir. Yes, sir.
Okay, so how you
Yes,
can,
sir.
so when you are connecting a circumferential part to a longitudinal part, you have to use some joints, then only you can connect. If you don't use joint, then it will be open in nature and your steam can get leak out from the boiler. Yes or no? Hello.
Yes, sir.
Fine. So
Yes.
for that case, we use rivet joint. So for those cases, we use rivet joint. So normally there are two type of rivet joints we used according to the shape of the boiler, because since we know that a boiler consists of two parts, one is the longitudinal part and another one is the circumferential part. So the two type of boiler rivet joints which we use are longitudinal butt joint and secondly the circumferential lap joint. I repeat, there are two types of rivet joint which we use in a cylindrical boiler shell. They are longitudinal butt joint and circumferential lap joint In today's class, we will see the design procedure of a longitudinal butt joint, and in next class we will go for the design procedure of this circumferential lap joint. Okay, since the plate of the boiler shell is bent in the form of ring and the two edges of the plate are joined to get a longitudinal butt joint. How you can get a longitudinal butt joint? The plate of the boiler shell is bent to form a ring and the two edges of the plate are joined by longitudinal butt joint. That means, I mean to say that this is one part. If you cut this boiler from the middle, this is one part, and this is the remaining part. This is boiler shell. It is made up of some material having some thickness T, okay, and this is somewhat long in shape like this. Fine. So what I am saying that how you can get a longitudinal butt joint? The plate of the boiler shell is bent to form a ring. You can see that this is the plate. I have bent it in the form of ring. This is the upper half portion of the ring. This is the bottom half portion of the ring, and the two edges of the plate are joined by longitudinal butt joint. So when you will join this upper half portion of the ring with the lower half portion of the ring in butt manner means you have to touch it like this. This is the upper half portion and this is the lower half portion. This is the butting process. Fine. So at this point or at this end, how you can join? You have to use some joint. Then which joint you will use? You will use this longitudinal butt joint. If you divide this entire boiler into say a set of n number of rings, that means this is one ring, this is one ring, this is another ring, likewise this is the last ring. Fine, see, this is the upper half portion of the ring and this is the lower half portion of the ring. You have to use a rivet in order to join. This is the upper half portion of the ring, this is the lower half portion of the ring. If you want to join it, you have to use some joint, and that joint is longitudinal butt joint. These are the longitudinal butt joint. And if you combine all these rings together, finally you will get a boiler, a cylindrical boiler. And these joints, which joint? These joints, these are called longitudinal butt joints. इज इट क्लियर? क्या समझ में आया क्या है लॉन्गिट्यूडिनल बट जॉइंट?
Yes, sir.
बाकी लोग को समझ में आया? हेलो?
Yes, sir.
Okay. Yes, sir. So this is your longitudinal butt joint. You can see that a longitudinal butt joint is a type of joint used to join the ends of the plate of the boiler to get the required diameter of a boiler. For this purpose, butt joint with two cover plate is used. That means this is upper half portion of the ring. This is upper half portion of the ring. This is lower half portion of the ring. You are joining it by a butt joint, that too a longitudinal butt joint. Ultimately what you are getting? You are getting the diameter of the boiler. So that is why it is written over here that a longitudinal butt joint is a type of joint used to join the ends of the plate to get the required diameter of a boiler. And for this purpose, normally we use a butt joint with two cover plate. Is it clear? कोई डाउट किसी को?
No, sir. Clear.
बाकी लोग बताओ कोई डाउट है? हेलो?
No, sir.
Okay.
No, sir. Clear.
Another type of rivet joint which we use in boiler to get the desired shape is your circumferential lap joint. So it is a joint used to get the required length of the boiler. For this purpose, a lap joint with one ring overlapping the other is used. So if you see the diagram, this is your circumferential lap joint. This is your circumferential lap joint. This is your circumferential lap joint. That means this is your circumferential lap joint and this is your longitudinal butt joint. Is it clear? By the
Yes.
help of longitudinal butt joint, we can get the diameter of the boiler shell, and by the use of circumferential lap joint, we can get the length of the boiler shell. Because ultimately, what we are doing, we are dividing this entire, means if we combine multiple rings and if we try to join it by the help of these two joints, that is basically the longitudinal butt joint and circumferential lap joint, we can get the entire shape and size of the boiler. So that's why circumferential lap joint is used for determining the length of the boiler, and longitudinal butt joint is used for determining the diameter of the boiler. Is it clear? कोई डाउट किसी को?
No, sir. No, sir.
Okay. So now let us move on to the design procedure of longitudinal butt joint. Let us move on to the design procedure of longitudinal butt joint. Before going to the design part, there are some assumptions which you need to keep in mind for designing the longitudinal butt joint. These assumptions are given in the book. You may go through these assumptions. I am not discussing it in detail. Okay, these are the 8 assumptions which you have to keep in mind while designing the longitudinal butt joint for the boiler. Okay, so let us go back to so let us design the longitudinal butt joint for a boiler. This is how a longitudinal butt joint for a boiler looks like. Normally we use triple riveted double strap butt joint. If you want, you may note it down somewhere. If I am designing a longitudinal butt joint for a boiler shell, we will use normally, if nothing is given in the problem, normally we will go for triple riveted double strap butt joint. Why? Because this triple riveted double strap butt joint can resist more pressure of steam, as compared to other type of riveted joint. Now this diagram, which diagram? This is the top view. This is the top view of your longitudinal butt joint for a boiler, and this is the front view. This is basically, say if this is my boiler, I have considered only one part. Say I have considered this part, this particular part. Okay, I have considered, because the shape is symmetrical, so I have taken the half portion. I have taken only this portion. Okay, so this is your shell plate, thickness of the boiler shell, denoted by symbol T. Thickness of the shell plate denoted by symbol T. And since we know that inside this boiler steam is generated and the pressure of the steam is very high, so we don't want any leakage of the steam from the boiler. So for safety purpose, we use double straps or double cover. You can see this is one cover on the top part of the boiler shell plate, and this is bottom cover on the bottom part of the boiler shell plate. Is it clear? क्लियर है यहाँ तक?
Yes, yes, sir.
बाकी लोग को क्लियर है यहाँ तक? हेलो, क्लियर है? फिर आगे बढ़ूंगा.
Yes, sir.
Okay, fine.
Yes.
So now there are two possibilities are there. Either these straps are of equal width, or they may be of unequal width. That means you can see that here, if I say assume T1 is the thickness of the outer strap and T2 as the thickness of the inner strap. So it may be a case that T1 is equal to T2, and it may be a case that T1 is not equal to T2. That means this is the thickness of the outer strap. This is your T1, and if I consider this inner strap, thickness is T2. Two possibilities are there. Either T1 is equal to T2 or T1 is less than T2. But the conditions, if say the condition is not given to you in the problem, then you will always assume that T1 is equal to T2. But if the condition is given in the problem that no, the outer strap is narrower and inner strap is wider in nature, then T1 will not be equal to T2, which is the case, and this is the second case which is described in this figure. You can see that the inner strap and the outer strap are having both separate thickness. Outer strap is narrower in nature and inner strap is wider in nature. So I will call this joint as triple riveted double strap butt joint with unequal strap. If both outer and the inner strap are of having same thickness, then I might have told that it is nothing but a triple riveted double strap butt joint with equal strap. Is it clear? क्या कोई डाउट है? हेलो हेलो कोई डाउट है?
Clear, sir.
Since we are using
No, sir,
three
clear.
rivets, since the name of the joint is triple riveted double strap butt joint, we are using three rivets, so we will get three rows. One row is your outer row, second row is your middle row, and third row is your inner row. And these things you know that intermediate distance between the two rivet in a single row is nothing but pitch P. Distance from width of one plate to the center line of the rivet is nothing but margin M, and so on. All these things are depicted in the figure. We are designing the longitudinal butt joint for a boiler. Designing means we are finding out the different dimensions of this boiler, of this joint. That means what is the value of thickness T, what is the value of T1, what is the value of M, what is the value of P, what is the value of PT, and so on. We are step by step we will be finding out all these values. Once we are done with all these values and all the values you have found out, later on what you will do, you will have to draw this particular diagram and you have to mark those values, then your design will be complete. Is it clear?
Yes, sir.
आपने डिजाइन कर लिया, आपने T1 निकाल लिया, थिकनेस ऑफ द स्ट्रैप निकाल लिया, थिकनेस ऑफ द शेल निकाल लिया, टी पिच ऑफ द रिवेट निकाल लिया, ट्रांसफर पिच निकाल लिया, बट आपको दिखाना भी तो पड़ेगा कि उस पर्टिकुलर लॉन्गिट्यूडिनल बट जॉइंट में कहाँ पे पी लाई कर रहा है, कहाँ पीटी की कहाँ से कहाँ तक है, एम कहाँ से कहाँ तक है. तो डिजाइन करने के बाद आपको सेम डायग्राम बनाना पड़ेगा, बनाने के बाद उसमें आपको डिनोट करना पड़ेगा दैट पी इज हाउ मच, M is how much, PT is how much, and so on. Okay, but ध्यान रखना अगर unequal है width, if the strap, if the width of the strap is unequal, thickness will be unequal. If thickness is unequal, you cannot make the same strap of same size. You have to make this is somewhat little bit bigger in shape like this. ये ध्यान रखना, अगर इक्वल है देन बोथ विल बी ऑफ सेम साइज, सेम शेप एंड साइज. ओके, एंड ऑल्सो एक इस बात का भी ध्यान रखना अबाउट दिस नैरोअर एंड वाइडर. नैरोअर मीन्स कुछ डिस्टेंस के लिए वी हैव यूज्ड this narrow strip. Wider means for little bit more, for somewhat some more distance we have used this wider strip. Okay, fine. So if it is clear to you, then we will start the design procedure. So shall I start? Shall I start the design process? Hello, start करूँ design process?
Yes, sir, you can start.
Yes, sir.
Okay. Very first step is you need to find out what the thickness of the boiler shell. Thickness of the boiler shell, that is T. Thickness of the boiler shell, that means this is your boiler. ठीक है, तो अब ये जो बॉयलर का जो शेल है, दिस इज कॉल्ड शेल, उसका थिकनेस कितना हो सकता है. This is the first part in the designing process of this longitudinal butt joint. So that thickness you can calculate from design data book page number 7.126. Let us check out page number 7.126. Okay, yes, you can see it is written over here. For longitudinal butt joint, thickness is how much? P into D divided by 2 times of eta L into sigma T. But there is a correction. This term will come as well as plus CA will also come. What is this CA? CA is nothing but corrosion allowance. I repeat, the thickness of the boiler shell plate will be P into D divided by 2 eta L into sigma T plus corrosion allowance denoted by symbol Ca. What is this corrosion allowance? It is the additional metal thickness required to withstand the internal pressure of the steam. I repeat, what is this corrosion allowance? It is the additional or extra metal thickness that is added on the boiler shell to withstand internal pressure. And this corrosion allowance lies from 1 millimeter to 2 millimeter. In between 1 and 2 millimeter you can take any value. Minimum limit is 1 millimeter and maximum limit is 2 millimeter. So finally your equation becomes thickness of the plate is P into D divided by 2 sigma T eta L plus 1 mm. What is P? P is steam pressure of the boiler in Newton per mm square. What is capital D? Internal diameter of the boiler shell in millimeter. Sigma T is permissible tensile stress for the cylinder material in Newton per mm square. And eta L, what is eta L? Eta L is the efficiency of the longitudinal joint. Again you can find out this efficiency from design data book page number 7.126. Let us check out page number 7.126. Yes, you can see this expression. Eta L is how much? Efficiency of longitudinal butt joint. For single riveted joint, efficiency lies from 0.6 to 0.8. For double riveted joint, it is from 0.75 to 0.85. For triple riveted joint, it is from 0.8 to 0.9. If in the problem the value of eta L is given to you, you have to use that particular value. If it is not given, then you have to identify which type of rivet joint you are going to design. If you are designing double riveted joint, you know that from data book the value of eta L varies from 0.75 to 0.85. In between any value you can take and you have to design the particular boiler joint. Is it clear? कोई डाउट किसी को फर्स्ट स्टेप में? कोई
No,
डाउट है
sir.
किसी को? हेलो,
No, sir.
बाकी लोग रिस्पॉन्ड करो, कोई डाउट है कि नहीं है?
No, sir.
Okay. After getting the thickness value, you have to check whether this thickness of the shell is less than 8 mm or if it is more than 8 mm. I repeat, after getting the thickness of the boiler shell, you have to check this thickness whether it is less than 8 mm or it is more than 8 mm. Fine. Normally, by using this expression, you should get the thickness of the shell less than 8 mm. I repeat, by using this expression, normally you should get the thickness of the shell less than 8 mm. Less than 8 mm. Okay, but But if the thickness of the shell is more than 8 mm, then what we will do? Then we will go to step number 2. What is step number 2? Step number 2 is we have to calculate the shank diameter of the rivet, that is small d. We have to calculate the shank diameter of the rivet, that is small d. So when thickness is greater than 8 mm, that means by using this particular expression you got the value of thickness. Then you will see whether thickness is less than 8 mm or more than 8 mm. If thickness is more than 8 mm, then the diameter of the rivet is calculated by an empirical formula called D is equal to 6 under root times of thickness. And this formula is known as Unwin's formula. Unwin was the scientist who discovered this formula. So on the basis of his name, this formula is being given. Unwin's formula. UNWIN''S. When thickness is greater than 8 mm. When thickness is less than 8 mm, you can check in the data book. It is already written that when thickness is less than 8 mm, you have to get the diameter of the rivet by equating the shear strength of the rivet, that is PS, with crushing strength of the rivet, that is PC. This is the case when dia is less than 8 mm. And this is the case D is equal to 6 root T when dia is greater than 8 mm. Is it clear? क्या कोई डाउट है? सेकेंड पार्ट ऑफ द डिजाइन स्टेप, कोई प्रॉब्लम किसी को? हेलो?
No, sir. No problem.
ओके, बाकी लोगों को कोई डाउट?
Yes, sir.
बाकी लोग प्लीज रिस्पॉन्ड करो, कोई डाउट है कि नहीं है?
No, sir. Clear.
ओके ओके ओके, fine. Third step is you got the value of diameter, you got the value of thickness from the first two steps. Third step is you have to find out what? You need to find out the pitch of the rivet. You need to find out the pitch of the rivet. Fine. How you can find out the pitch of the rivet? Either you will equate the tensile strength of the rivet with the shear strength, or you will use the empirical relation, that is P max is equal to C into T plus 41 mm, where T is your thickness of the plate and C is a constant which is taken from the boiler design data book code. C is a constant which is taken from boiler design data book code. Fine. So that means firstly you will equate PT with PS. You will get one value of pitch P. Secondly, you will use the empirical relation P max is equal to C into T plus 41 mm. You will get the value of P. Then which P you will take? Either then you have to take the least of the two values. If by using this expression pitch is minimum, you have to use this pitch further for design process, or you get the value of pitch P minimum by using this expression, then your corrected pitch will be this particular value, and then you have to use this value and you have to design the other, you have to get the dimensions of the other part of the problem. And this particular empirical relation is again given in the design data book. It is again given in the design data book, that is, see, Page number 7.126, it is given. Pmax is C times of T plus 41 mm. Is it clear? कोई डाउट है किसी को? पिच ऑफ द रिवेट कैसे निकालेंगे? दो तरीके से आपको निकालना पड़ेगा। पहले आपको पीटी को पीएस के बराबर करना पड़ेगा, उससे एक पिच आएगा। सेकेंडली आप यूज करोगे एम्पिरिकल रिलेशन फ्रॉम द डिजाइन डेटा बुक, दैट इज सी टाइम्स ऑफ टी प्लस 41 mm, उससे एक पिच आएगा। तो दोनों में से जो लीस्ट पिच होगा उसको लेके मैं डिजाइन करूंगा। इज इट क्लियर? कोई डाउट? हेलो,
Yes.
बाकी लोग को क्लियर है?
Yes.
बाकी लोग
Clear,
जल्दी
sir.
रिस्पॉन्ड करो। क्लियर है? ओके। Now see, in this expression Pmax is equal to C times of T plus 41 mm. What is C? C is a boiler code constant. For that again I have to go back to my data book. Let us go back. You can see for rivet joint for pressure vessels, page number 7.126, how you can get the value of C from this table. From this particular table you can get the value of C. Since we are talking about butt design procedure of butt joint, so either we will see this particular table or we will see this particular table. If the longitudinal butt joint which you are designing, if it is single cover, then you will see this table. If it is of double cover, then you will see this table. Now if the number of rivet per pitch length is 1 and if double cover is used, then value of C is 1.75. If in the problem it is told to you that the number of rivets per pitch length is how much? 4 and single cover is used, then C is not defined. In that case you have to take C as 1 mm and solve the problem. But if you are using, but if number of rivets per pitch length is 4 and you are designing for double cover butt joint, then for that case I know that the value of C is 5.52 and then I will calculate the value of Pmax and so on. So this is the way by which you can find out the value of C. Is it clear? कोई डाउट किसी को? हेलो, कोई डाउट है?
No, sir. No doubt, sir.
ओके।
Yes.
थर्ड स्टेप, ये तो मैंने डेटा बुक से लिया है पिक्चर उठा के। ओके फाइन। नेक्स्ट फोर्थ स्टेप, fourth step is you have to calculate the design distance between the rows of rivet, which is also known as transverse pitch, which is also known as back pitch, denoted by symbol P suffix B or P suffix T. Again, for calculating PB and PT, we have to use design data book. Till the third step, what I know the value of pitch P, I know the value of shank diameter D. Now I want to find out the value of back pitch and transverse pitch. Again, go back to the design data book. You can get the value of back pitch by using this condition. You can get the value of back pitch by using this condition. See, you can, if it is chain riveted, then these two options are available, and if it is zigzag riveted, then these two options are available. Okay. Again, if you see, you will use this particular equation only when there are equal number of rivets in all rows. But if the number of rivet in outer row is half the number of rivet in inner row, then for chain riveted joint, back pitch is given by this expression, and for zigzag riveted joint, back pitch is given by this equation. So you have to clearly read the problem. In the problem, which condition is given to you? If no condition is given to you, you can assume equal number of rivets in all rows. But if a specific condition is given to you, you have to read the problem thoroughly. From that part, you have to pick that particular condition. Accordingly, you have to get the value of PB for chain riveted joint and zigzag riveted joint. Is it clear? क्या समझ में आया कैसे निकालूंगा पीवी और पीटी? कोई डाउट?
No, sir.
बाकी लोगों को कोई डाउट किसी को? हेलो, बाकी लोग प्लीज रिस्पॉन्ड करो, कोई डाउट है कि नहीं है? कोई डाउट है किसी को?
No, sir, clear.
Yes, sir.
ओके फाइन. In the data book C, it is written that PB is greater than or equal to 2D. Either it is greater than or equal to this particular value. Normally, we don't take the greater than case, we take the equal to case. So you can see that here I have written the equal to case. Normally, we don't go for greater than case. Okay. Next step. The fifth step is thickness of the butt strap. We have to determine the thickness of the butt strap. That means this one. If you see the diagram, so far what we have calculated? We have calculated the value of small t. We have calculated the value of pitch P. We have calculated the value of transverse pitch PT, and we have calculated the diameter of the rivet. We have calculated the value of this diameter of the rivet, that is D. Next step is we have to calculate the thickness of the strap, that is this particular thickness, that is T1, thickness of the strap. This I have to determine in the next step. So thickness of the butt strap, again I can find it out from the design data book. So again I have told you that two conditions are available. Either the cover plates may be of equal width or it may be of unequal width. If it is of equal width and if you have used only single cover for your boiler joint, then you have to use thickness T1 as 1.125 times of T, and for double cover the thickness of the butt strap becomes 0.625 times of D, and for unequal straps or unequal width of the cover plate, for the wider one thickness becomes 0.75 times of T, and for the narrower one the thickness, that is T2, becomes 0.625 times of T. So let me show you in the data book where it lies. Okay. Yes. Page number 7.127. Page number 7.127. You can see these particular things. Now for single cover, thickness is 1.125 times of T. For double cover of equal width, thickness T1 is 0.625 times of T. And this is for now this particular data is valid for equal width cover plates. I repeat, this particular data is applicable for equal width cover plate. Fine. Now if your cover plate is if you have used single cover plate with the outermost row having alternate rivet, then this particular equation is used to get the value of thickness of the strap. And for double cover plate, when the outermost row is having alternate number of rivet, then the thickness of the butt strap is given by this particular expression, where P and D are nothing but pitch and dia of the rivet. And for unequal width of cover plate, this is the expression. For wider one, thickness is 0.75 times of T. For narrower one, thickness is 0.625 times of T. Again, you have to read the question very carefully. Which type of strap or cover plate is being used in the problem which you are going to design? According to that particular strap, you have to select the thickness value of the butt strap. If nothing is given in the problem, always go for equal width strap values. Is it clear? कोई डाउट किसी को? कैसे निकालूंगा मैं ये थिकनेस ऑफ द butt strap from data book? कोई डाउट?
No, sir.
No, sir.
Okay, fine. So this was the fifth step and the last step in the design process of this longitudinal butt joint is to calculate the margin. And I know that margin is nothing but 1.5 times the shank diameter. This is also given in the data book. Let me show you where it is given. See this particular expression. Margin of the longitudinal butt joint is nothing but M is equal to 1.5 times of D. Since D is nothing but your diameter of the rivet, which we have calculated in the second step. So with the help of that particular value, we can get the margin of the rivet. Once we get all these values, you have to draw this diagram according to the given condition, whether the straps are equal or unequal, and you have to mark those values which you have got. For example, if you have got P is equal to 50 mm, you have to mark the value. If you got PT equal to 24 mm, you have to mark the values, and so on. So this is the complete design procedure of longitudinal butt joint which we use for boiler shell. Any doubt in this design procedure? कोई डाउट है किसी को?
No, sir.
Okay. So
Yes.
let us solve or let us design one problem related to this longitudinal butt joint. After this, we will end up this class over here and we will again meet in the next class with the circumferential lap joint. Okay. So let us take one problem. The problem is design a double riveted zigzag butt joint with two cover plates for the longitudinal seam of a boiler shell 1.5 meter in diameter, subjected to a steam pressure of 0.95 Newton per mm square. Assume joint efficiency as 75%. Allowable tensile stress in the plate is 90 megapascal, compressive stress 140 megapascal, and shear strength in rivet is 56 megapascal. Make a check for efficiency. That means what is given in the problem? You have to design a double riveted zigzag butt joint. That means value of n is 2 because double riveted we are using which type of butt joint? Zigzag type of butt joint with two cover plates. That means it is a case of two cover plates and we are designing the longitudinal seam of a boiler shell of 1.5 meter diameter. This 1.5 meter is what? Diameter of the boiler shell, that is capital D, is given to you. Steam pressure capital P is given to you, which is how much? 0.95 Newton per mm square. Joint efficiency is given to you, that is 75%, and sigma T, sigma C and tau is given to you. So firstly we will design the all the specifications of this particular joint, and then we will find out the efficiency of the joint. Is the question clear to all of you? कोई डाउट है किसी को क्वेश्चन को समझने में?
Yes, sir.
क्लियर है? ओके अब आप देखो इस
Yes.
क्वेश्चन में कहीं पर भी ये नहीं बोला है कि जो कवर प्लेट आप यूज कर रहे हो, कवर प्लेट दैट इज नथिंग बट योर स्ट्रैप, दैट इज ऑफ इक्वल विड्थ और ऑफ अनइक्वल विड्थ। बोला है कहीं पे क्वेश्चन में कि अनइक्वल विड्थ का कवर प्लेट है या इक्वल विड्थ का कवर प्लेट है? It has not been given in the question. If it is nothing has been mentioned regarding the structure of the cover plate, whether it is of narrower width or of wider width, fine, always we will assume that both the two cover plates are of equal width. Correspondingly we will get the value of T1, because there are different conditions for in order to get the value of T1. So we will choose the correct condition, that is equal width condition we will choose, and we will get the value of T1. So let us design the problem. The first step is what? First step is thickness of the boiler shell. I know that thickness is nothing but P into D divided by 2 sigma T eta L plus CA. CA is corrosion allowance. I know that it varies from 1 to 2 mm. I have taken it as 1 mm. You may take it as 1.5, 1.4, 1.3. It's your choice. But it should be in between 1 to 2 mm. So pressure is given in the problem, internal pressure. Dia of the shell is given in the problem, capital D. Sigma T and eta L is given in the problem. Just substitute all these values, you will get the thickness of the boiler shell, that is 11.55 mm. Any doubt in the first step? कोई डाउट है किसी को?
No doubt, sir.
Okay. But remember one thing, you have to mention the page number of the data book from where you have taken this data. If you don't mention page number, you will lose marks every time. Whenever you are taking any data from data book, say in a single problem, if 10 times using the you are taking the help of data book and you are writing down some equations, then 10 times you have to mention the page number, even if the page number is same. Is it clear? समझ में आया?
Okay, sir. Yes.
Because you are designing an equipment. When you are designing an equipment, you have to give all the detailed calculation part. Fine. Okay. Second step is we have to find out the diameter of rivet. I have told you that in order to get the dia of the rivet, you have to check two conditions. First condition is whether the thickness is greater than 8 mm or thickness is less than 8 mm. So I can see that my thickness value is 11.55 mm, which is greater than 8 mm. So, and I know that if thickness is greater than 8 mm, which formula I will use? I will use Unwin's formula. But if thickness is less than 8 mm, which equation I will use? I will equate PC, crushing strength, with shear strength PS. Then I will equate those two equations and we will get the value of diameter. Here, since thickness is greater than 8 mm, so we are going for Unwin's formula, that is D is equal to 6 under root T. T already we have calculated, that is 11.55 mm, under root of 11.55 into 6. So basically the diameter of the rivet is coming out to be 21 mm. Second part of the design step. Is it clear? कोई डाउट है इस सेकेंड स्टेप में?
No, sir.
Third step is what? Calculation of the pitch of the rivet. So if you remember, I have told you how we can calculate the pitch. two options are possible. So that is, firstly you have to equate PT with PS, you will get one pitch value. Then you will use the empirical equation, that is Pmax is equal to Ct plus 41 mm, you will get another pitch value. Out of these two value you have to go for the least value of the pitch. So firstly let us evaluate PT equal to PS and get the pitch value. So this is the equation of PT. I know that is P minus D into T into sigma T, and PS. PS is N into pi by 4 D square tau into 2. Why 2? Because the type of joint is double riveted zigzag butt joint. Double riveted means two times shearing is taking place. So if two times shearing is taking place, then the shear strength becomes two times of, that means number of times of shearing into n into pi by 4 d square tau. So here number of shearing is how much? Two times of shearing is happening. So 2 into n into pi by 4 d square tau. Here again the value of n will be 2. Why? Because we are using double riveted joint. And so just equate PT with PS, you will get the value of pitch, and that pitch is 95.96 mm or near about equal to 96 mm. But this pitch, it may be a correct pitch, it may not be correct pitch. For that we have to again evaluate the value of pitch by using empirical relation, that is Pmax is equal to Ct plus 41 mm, which I can get from data book page number 7.126. Fine. Okay. But in this particular expression, T I know, that is 11.55 mm. C is nothing but a boiler code which I have to get from design data book. So let us go back to design data book. Okay. So if I go to page number 7.126, this is the table for getting the value of C. Since we are talking about butt joint, so we will eliminate this particular table. And in butt joint, two options are available: single cover and double cover. So let me check our problem, which cover is there. So in my problem, which cover is given? That is, design a double riveted zigzag butt joint, two cover plates, that means double cover is there. So if double cover is there and number of pitch is 2, then the value of C will be how much? 3.5. Value of C will be 3.5. So just substitute the value of C as 3.5 and remaining values you know, you will get the value of Pmax, that is 81.425 mm or near about equal to 82 mm. So if we compare P and Pmax, Pmax is smaller in is a smaller value. So the corrected pitch of the given riveted joint is how much? It is 82 mm, not 96 mm. Is it clear till third step? कोई doubt है किसी को?
No, sir.
बाकी लोग रिस्पॉन्ड करो, कोई डाउट है कि नहीं है थर्ड स्टेप तक? हेलो, क्लियर है?
Clear.
ओके. फोर्थ स्टेप क्या था? फोर्थ स्टेप इज you have to calculate the distance between row of rivet or back pitch or transverse pitch. For that again I have to use the equation, and that equation I can get from the design data book. So let us go back to design data book. So this is the table by which I can get the value of back pitch PB or transverse pitch PT. So you can see two conditions are available for chain riveted and for zigzag riveted joint. So I have to check my question which type of joint is there, whether it is chain or zigzag riveted. I can see that it is a zigzag riveted joint. So then I have to eliminate this particular table. Next, we have to check whether it is the case of equal number of rivet in all rows, or whether it is a case of number of rivet in outer row is half the number of rivet in inner row. If you see the problem, this nothing is told about this particular condition. If no information is there in the problem for the condition part, then always I will assume this first condition for simplicity, that is equal number of rivet in all row for zigzag joint. PB is how much? It is equal to 0.33 times of T plus 0.67 times of D. See, 0.33 times of P plus 0.67 times of D, where small p is pitch of the rivet, already we have calculated. Small d is dia of the rivet, we have calculated. Just substitute these values in this particular expression, you will get the transverse pitch or back pitch of the rivet, that is 41.13 mm. Is it clear? Fourth step, कोई डाउट है किसी को?
No, sir.
बाकी लोग रिस्पॉन्ड करो, क्लियर है कि नहीं है? क्लियर है?
Yes, sir.
Okay. Next step is, that is fifth step is thickness of the butt strap. Thickness of the strap or thickness of the cover plate we have to determine again in the given problem. So for that again I have to go back to the data book. If I see my data book, page number 7.127. Yes. This is the table from where we can get the value of cover plate thickness or strap thickness. Two conditions are available. One is when the width are equal, then these are the conditions, these are the valid equations, and when width is unequal. If you read the problem, let us see which condition is given in the problem. Design a double riveted zigzag butt joint with two. No condition is given regarding this butt strap. No condition is given. So if nothing is given in the problem, always I will assume for equal. Always I will assume for equal width strips. So if you see that in equal width strips, four equations are available. Which equation I have to use? Again, these equations depend upon the type of cover, whether it is a single cover or it is a double cover. For that, again, we have to read our problem. It is what? It is a double cover plate. So if it is a double cover plate of equal width, thickness of the strap is how much? 0.625 times of T. 0.625, that is T1 is 0.625 times of T. See, T1 is 0.625 times of T. T already we have calculated, so it is 0.625 into 11.55 mm. That is 8, near about equal to 8 mm. That is thickness of the strip. Both the strip, outer strip strap as well as the inner strap is how much? 8 mm thickness. Is it clear till the fifth step? कोई doubt किसी को?
Clear, sir.
Okay. And the last step is what? Last step is calculation of margin. We know from the data book that margin is how much? It is 1.5 times of D. That is 1.5 into 11.88. Sorry, D is dia of the rivet. Dia is how much? Dia is 21 mm. Sorry, 21. So it is 1.5 into 21, which is near about equal to 32 mm. So this is the margin of the rivet. So we got all the possible dimensions for the riveted joint. Fine. Then what you will do? You have to draw this diagram. Once the design is over, all the data we got, we have to draw this diagram, and in this diagram we have to indicate how much is P, how much is PT, how much is T1, how much is T. Then your design will be complete. If you don't draw this diagram, then how I will understand that for the longitudinal butt joint what is your P, or how much, from which point to which point is your pitch, from which point to which point is your thickness of the outer strap, and so on. Is it clear? Quick doubt?
No, sir.
Okay, fine. So with this we have completed the, yes, fine. So we were in the step number, yes. So after this margin, we will draw that particular diagram and we will indicate all the values. The last part of the problem is we have to check the efficiency of the rivet joint which we have designed just now. For that, we have the equations of the efficiency, that is eta is equal to minimum of either PC or PT or PS divided by PET sigma T, where this P is your pitch of the rivet. This P is your pitch of the rivet. PT, you know the equation. PS also the equation you know, and PC also the equation you know. You use these three equations and get the value of PT, PS and PC. So out of PC, PS and PT I can see that this PT value, I can see that this PT value is the lowest of PS and PC. So the efficiency of the joint is PT, that is 63409.5 divided by pitch into thickness into sigma T. Pitch we have calculated, that is 82 mm, into thickness is 11.55, into permissible tensile stress given in the problem. Just solve it, you will get the efficiency of the joint, and that is equal to 74.39%. So this is the complete design procedure of longitudinal zigzag butt joint. Similar type of problems are available in the example part as well as in the exercise part of the VV Bhandari book. So please solve those problems. Okay. कोई doubt यहाँ तक?
Okay, sir.
Okay.
No, sir.
So
No, sir.
fine. So with this we have completed this first part, that is design procedure of longitudinal butt joint. In the next class we will discuss the design procedure of circumferential lap joint, and we will see one design problem. After that, one more topic is left, that is eccentric loading of riveted joint. With this we will end up this module over here. So with this I am ending my today's lecture over here. So if you are having any kind of doubt, you may ask. Thank you.